Good morning, everyone. Thanks for joining us today for the Montana Wildfire Risk Assessment webinar hosted by the Northern Rockies Fire Science Network with presenters from the Montana Department of Natural Resources and Conservation and Pyrologix LLC. I'm Signe Larafalem, coordinator for the Northern Rockies Fire Science Network. In case you're unfamiliar, we are one of 15 regional fire science exchanges funded by the Joint Fire Science Program. We're dedicated to delivering science and providing opportunities for land managers and researchers to engage about important fire and fuels topics in the region. To learn more, please visit our website at nrfirescience.org. Just a couple of housekeeping items before we get started. All attendees are in listen-only mode for this webinar, but we encourage you to ask questions, both of me or our presenters at any time by typing them into the questions or chat pane of the webinar control panel. These questions will facilitate discussion following the presentations. And just so you're aware, the webinar is scheduled for 2 hours or perhaps longer, including questions. If you need to dive off, rest assured that a recording of the webinar will be available on the Northern Rockies Fire Science Network website and YouTube channel within a day or two. All attendees and folks who registered will receive an email with a link to that recording once it's available. And I'll also try to post that link in the chat window. And with logistics out of the way, I'd like to go ahead and introduce our presenters. Our first presenter will be Matt Hall, who's been a wildland firefighter with the Montana DNRC for the last 20 years. He was the fire management officer at the Southwestern Land Office, but recently moved into a new position at the Fire Protection Bureau as the Planning and Intelligence Program Manager. After Matt, we'll hear from Joe Scott, who is the Principal Wildfire Analyst with Pyrologix, based in Missoula, Montana. Joe made his first wildfire simulation 32 years ago when he thought that 13 fuel models were too many to commit to memory. He now has more than 25 years of experience in wildfire behavior modeling research, development, and application. Joe has led projects related to surface and canopy fuel characteristics, wildfire behavior modeling, ground fire hazard assessment, and wildfire risk assessment. Together with the analysts at Pyrologix, Joe conducts wildfire hazard and risk assessments to support land management planning, incident management, and utility wildfire risk management for state and federal agencies and private companies. Following Joe's presentation, we'll hear from Brian Collins, who is the IT GIS Program Manager with the Montana DNRC. And finally, Julie Gilbertson Day will share some visuals and demos during the Q&A. Julie is the program manager at Pyrologix. She has more than 10 years of experience in wildfire research, development, and application, with an emphasis on integrating resource and asset data with wildfire hazard information in wildfire exposure and effects analyses. Julie's past research efforts include data and scale issues related to wildfire modeling and wildfire risk assessments, downscaling wildfire risk assessments, and analysis of historical fire occurrence and suppression expenditure data. Thank you so much to Matt, Joe, Brian, and Julie for being here today. Matt, you can go ahead and get started when you're ready.
Hey, good morning. Thanks, Signe. Hey, first we wanted to let you know that we just really appreciate your efforts in coordinating and hosting the webinar today. We're quite excited for the first real opportunity for DNRC and the Northern Rockies Fire Science Network to come together and collaborate, so thank you. And good morning to all the attendees who have tuned in today. It's a real pleasure to be here with you this morning. As a Fire Program Planning and Intelligence Program Manager, I know that we at the DNRC consider this risk assessment to be of strategic importance and has put us on a course for data-informed action in our agency. For a little background on this project, the funding was obtained in 2018 through a Western States Fire Managers Wildland Urban Interface Grant. This money is made available through the U.S. Forest Service's State Fire Assistance Program, which plays a critical role in our state's ability to support community-based wildfire risk mitigation and fire prevention outreach and education. In August last year, the DNRC signed a contract with Pyrologix, who is really the leading company when it comes to wildfire analysis. We were fortunate that they were able to fit us into their schedule, as we had a much shorter timeline for completion than they would have liked. But we were able to kick off a grueling series of workshops over a period of 5 months. We started in October with the Fuels Calibration workshop. We then completed the resource and assets identification in November, And then right before Christmas, completed the fire effects workshop, with the final workshop being the relative importance assignments, which was finished in late February. This brings us to today, getting to see the initial results of the Montana Wildfire Risk Assessment. But this project is far complete for us at the DNRC. Moving forward, we will be working with our wonderful GIS staff over the next several months to make this enormous amount of geospatial data available through an interactive web map and open data portal. Over the past few years, the DNRC Forestry Division has been working wildfire risk resources and tools for both practitioners and the public into our programs. This started with the development of the Wildfire Home Risk Assessment Portal for homeowners to learn more about their home's susceptibility and exposure to wildfire risk in Montana, and lays out the steps they can take to lower the ignition potential for their homes. The Montana Wildfire Risk Assessment is another step for the DNRC in providing tools for planning, prioritizing, and implementing cross-boundary work throughout Montana and within the Forestry Division programs. The assessment represents a collaborative effort between the DNRC and our interagency cooperators in Montana at both the federal and local government levels, and we truly thank them for their contributions. This project will assist DNRC in meeting our primary fire protection mission of protecting lives, property, and natural resources from wildfire by providing safe and effective services to Montana citizens, as well as leadership, coordination, and resources to the state's wildfire organizations. It will also support our forestry assistance efforts to provide services to communities and private landowners to promote sustainable forests and watersheds for the benefit of all Montanans. This project adds capacity by providing the best available data to planners, fire and natural resource managers, the public, local collaboratives, and policymakers at multiple levels. It can be used in a wide range of applications, including planning, prioritizing, and implementing hazard mitigation, fire prevention activities, and projects, updating community wildfire protection plans, hazard mitigation plans, as well as land and resource management plans, allowing us to leverage our resources and capabilities across the state. The risk assessment will function as a decision support tool, allowing key stakeholders to collaboratively address our most pressing wildfire risks in Montana. In the end, it will enable decision makers on the ground to take a focused and deliberate actions to prepare and protect our communities. We would like to thank all the interagency cooperators and DNRC staff who participated in the calibration and planning workshops throughout this project. And finally, we'd like to thank Pyrologix for their critical role they've played with the development of the wildfire risk assessment, as well as their continued support in making this available, the data available to everyone in the months ahead. It's been an absolutely great experience to work with Joe and Julie and the staff at Pyrologix. They're truly a premier group when it comes to wildfire analysis. So thank you. And with that, Signe, I'm going to turn it back over to you.
Okay, thanks so much, Matt, for that intro. I think we're ready to hand things over to Joe Scott for the main presentation. Joe, you can get going whenever you're ready.
Okay, and can you hear me?
Yes.
Okay. Well, here we are. It's been not a long road, like Matt said. It's been a compressed time frame. But what we're going to talk about this morning in the next couple of hours are a background on some of the concepts of wildfire risk assessment, just so that everybody is on the same page with our terminology. And then we'll talk about this project, a little bit of the background, how we did the fuel calibration, the wildfire simulation, selecting and the resources and assets, and then we'll, at the end, we'll talk about the results. But before we get started, like Matt was just saying, need to acknowledge the entire staff at Pyrologix. This is a group photo of the modern era. We had to transition over to remote work like everybody else about a little over a month ago, and so our group photo is, of course, from Slack or from the Zoom meeting. That we actually wrapped up this whole project remotely, which was a little bit of a challenge, but we got it done. Okay, let's talk about some concepts. First of all, wildfire is a natural hazard, like others, and technically we should call it a peril, which is a source of of risk to people, to assets, or to natural resources, a natural peril, like earthquakes and hurricanes and tornadoes. And right in the center there, the most deadly natural phenomenon is actually just heat waves in terms of how many people are killed annually across the globe. So really, the framework that we're going to talk about and that we use here, we apply it to wildfire, but it actually has broad application among all of these different natural hazards. And then the framework is really this. It's like, I've been calling it kind of a 4-box model of wildfire risk, or the risk framework, where you have probability, intensity, exposure, and susceptibility. And we'll talk some more about each of those in detail. But if you've heard of some other ways to think about risk, here's one. It's the combination of hazard and vulnerability. Well, where hazard is probability and intensity, and vulnerability is exposure and susceptibility. And then there's a third way of thinking about it, likelihood and consequence, or probability and outcome or impact. And that's simply still the 4-box model, but 3 of them, intensity, exposure, and susceptibility, combined become the consequence or impact, or the conditional net value change, for example. So a few more details on each of those things. A hazard, again, is a physical situation that has potential for harm to people or damage to natural resources and human assets. So it's the likelihood of a damaging event occurring and the potential intensity or magnitude of that event if it were to occur. So you can have a hazardous situation but no vulnerability, so no risk. These skiers here are assessing the size, potential size, and the likelihood of an avalanche. So they're doing avalanche hazard assessment. And then after skiers assess hazard, they manage their risk by controlling exposure, which we'll see later on. Probability is just simply the likelihood that an event will occur during a specified period of time, and with wildfire, for a specified spatial domain, whether it's just one point in the landscape or an entire county or something like that. So it has a space and time component to it. So with wildfire, the space component is usually a very small area of the landscape. We can get down to individual pixels. So maybe not quite the 30-meter quarter-acre size, but something around 10 acres or less. We have an estimate of the likelihood of it burning annually. So it's an annual burn probability for all of our work that we're going to show you here today. Intensity is the rate of energy release of an event. And intensity is usually considered to be the effects causing characteristic of a natural phenomenon, including wildfire, but for others as well. For instance, hurricanes or tornadoes, their intensity is measured by wind speed. And wildfire intensity, obviously, we measure that with fire line intensity, Byram's fire line intensity, or like as we do here with flame length. Avalanche intensity is called destructive potential. So earthquakes, we have actually it's the modified Mercalli scale of intensity, and the Richter scale for magnitude. So the intensity and magnitude works for a variety of different natural hazards. Vulnerability, as I mentioned, is that combination of exposure and susceptibility of an asset, a resource, or a person. That exposure to a peril. So for instance, exposure to wildfire, or in this case, exposure to avalanche. So the skier is exposed to an avalanche by choosing to ski in that terrain. And it's just inherent that all skiers, all human beings, are susceptible to being harmed by avalanches, although they can control that susceptibility a little bit, as you'll see. So exposure and susceptibility is that vulnerability. So exposure is kind of the spatial coincidence of hazard, so likelihood and intensity, and a person, resource, or asset. In many cases, exposure is a choice. So here, the skier has chosen to expose himself to the peril of an avalanche by deciding to ski that slope. People choose to build or purchase a home in a fire-prone environment. But other times exposure is inherent. So exposure of wildlife habitat to wildfire is not a choice, that's inherent. And communication sites, for example, they have to be sometimes placed on certain locations on mountaintops, regardless of the perils of doing so. So natural resources, for sure, the exposure is inherent. That's not a choice at all. Susceptibility is the propensity for harm to people or damage to resources or assets as a result of being exposed to an event, a wildfire event of a given intensity. And here it's exposure to an avalanche event. So the skier is wearing, that's an avalanche airbag. This is not how you normally ski with it, but it's been deployed. And the idea is that in an avalanche, you deploy the airbag, and the airbag keeps you on the surface. It keeps you from being much less likely to be buried by the avalanche. So it's reducing your propensity for harm. Definitely does not eliminate it. So with wildfire, fire safe building practices reduce the susceptibility of buildings to damage from wildfire. And then there's a new concept that I haven't talked about in these my risk assessment framework, and it actually doesn't really fit in. That in our framework, I'm calling it sensitivity, because so the susceptibility of a house to wildfire damage, given that it's exposed, is a function of its building characteristics. But some people are more sensitive to that damage than others because they have less, it's called adaptive capacity, less ability to adapt to the damage that occurs. So in this framework, we're calling that sensitivity only because the term vulnerability, which is what social scientists use to call this vulnerable populations, we've already used it. It already has a role in this framework, and it has for a long time. So we call it sensitivity that kind of goes along with susceptibility. And then risk is putting all of that together. So risk, you can consider it the potential for realization of adverse consequences of an event or of a peril to people, to assets, or to natural resources. So risk requires that all four components, all four boxes of wildfire risk must be present. Hazard and vulnerability, so probability, intensity, exposure, and susceptibility all have to be present. And so they're all present here. In fact, the exposure, you can see that there's some snowmobile tracks over the mountains, so that there was the likelihood of the event occurring, the intensity was high enough that it could cause harm to people. And there were people exposed to that slope, and people are susceptible. So here's an image of all four boxes of risk. Okay, and you've heard me talk about assets and resources and things. So an asset is simply a human-made object of use or value to its owner. So homes and other buildings, like a lookout, communication towers, electric power transmission infrastructure, things like that. So wildfire can damage assets, and that results in loss. With very, very rare exceptions, assets do not benefit from fire. Resources, natural resources, are something that are found in nature. They're necessary to people or useful to us. And so wildlife habitat, forage, timber, watershed resources, for example. So resources can be damaged by fire, and in some cases they can also benefit. And then you're going to see this term HVRA, highly valued resources and assets. And so it's a resource or asset that is worthy of special consideration and likely to warrant protection if found to be at risk. That's the real criteria, likely to warrant protection if found to be at risk. So if we run through some lists of potential resources and assets to address, and then decide that this vault toilet, for example, we find that it's at risk and decide that it actually doesn't warrant protection, then we simply don't include it in the assessment, that it isn't highly valued enough, so it's not an HVRA. Burn probability is the probability that fire will burn a given point or sometimes an area during a specified period of time. So most landscape scale risk assessments, like this one for Montana, are based on an annual burn probability. Some approaches rely on a relative burn probability or a conditional burn probability that does not necessarily equate to an annual likelihood. And then flame length probability. So most of us are accustomed to either observing or simulating flame length in a given fuel bed, and there's only one for a given weather condition, and whether the fire was heading or flanking or backing. And in that a fuel complex can burn, the range of intensities that could happen. And the way we do that is to bin up flame lengths into, for this assessment, it's into 6 bins that cover the full range of flame lengths, because the upper bin is anything above 12 feet. So the same fuel complex can burn at relatively low intensities. Get the laser pointer. Relatively low intensities if the fire is backing fire, or it's early in the morning, we get low intensity fire. And then in other conditions, there might be a higher intensity fire with stronger winds, drier fuels at the head of the fire, and then higher intensities yet. And then finally, all the way up to, this is obviously way above 12-foot flames. But for effects analysis, we usually consider anything above 12-foot flames is usually a high severity fire, and the effects on natural resources and on assets and on people is extreme no matter what. So flame length probability, FLP, you might see that for a little bit. Okay, so that's a little bit of the background of some of the concepts and the terminology that you're going to hear for the rest of the morning now. And we'll now talk about the risk framework itself. And yes, there's going to be a little bit of math, some equations to look at here, but it won't be too bad. And so like a lot of the work that we rely on for spatial fire modeling in the US and actually around the world really, this risk framework originated with Mark Finney, who works with the Forest Service at the Fire Lab here in Missoula. And he wrote a paper in 2005 called The Challenge of Quantitative Risk Analysis for Wildland Fire. And that really, what we're doing today is still what he proposed in that paper 15 years ago. And 5 years after that, some other Forest Service researchers worked on this paper called The First Approximation of Hazard and Risk Across the Country. And then another 5 or 8 years after that, here in Missoula, we also worked on, it's now the GTR 315. It's called really the framework that we're using. It's really just a fleshed out version of what Mark started, and the first approximation continued long before it. And then this is what Mark, his equation, his framework. He called it a definition of fire risk, this equation, but I like to think of it more as a measure of fire risk than an actual definition. He said it has 2 main factors. So one is the fire behavior probabilities, the PFI. So the probability of fire of given intensity classes. That actually has probability and intensity combined into one number. So fire behavior probabilities, and then also fire effects, which he had separately here as the benefits and losses due to wildfire. So he was already acknowledging that wildfire can convey benefits to some resources or assets. Oh, actually mostly to resources, right? And then here he's got I and a J. So I is every pixel across the landscape, every small local area, and J is that there are different resources and assets that you have to add up. So you add up the risk to houses, the risk to watersheds, and the risk to transmission infrastructure, for example. And then you'll notice that the Mark's equation and the 4-box model fit very well together. So what we call risk there is his expected net value change. That's the good measure of risk. Probability of fire of given intensity classes is, like I said, it's both of these hazard and probability into one part of it, and then susceptibility and sensitivity. We can't actually address that in these risk assessments, this framework, but the susceptibility is the benefits and losses of fire if it were exposed to different intensity classes. So everything fits there. Exposure actually fits as well, because you apply this equation for every pixel across the landscape, and that inherently relates the location of a resource or asset with the probability intensity at that location. So it's inherent there. And then it's also kind of nice that we can look at this 4-box model of risk and see that most of our fire management actions, the things that we do pre-season, during the fire season, after the fire season, a lot of it fits very nicely on in the 4-box model. So how do you reduce the probability of fire? Well, it's through the prevention program and preparedness or initial attacks. So we prevent fires from starting or keep them small, therefore they can't burn area. When they do escape initial attack, if we perform some large fire suppression, that's the idea, is to keep the fire smaller. Usually that's the idea, is to keep it smaller. And then landscape scale field modifications can keep fire smaller. And anytime you reduce the number or sizes of fire, you're inherently reducing the likelihood of fire burning any point in the landscape. To reduce intensity, that's a field modification. Defensible space is really a field modification right around a home or other asset or anything that would like to be protected. Exposure is not as much that land management planning can do about it, but it's really evacuation. So when an incident starts, evacuating the people is controlling exposure. And then land use planning. So if you were trying to control exposure of houses to wildfire in a land use planning context, then that's really controlling exposure. And then lastly is susceptibility. So asset hardening, deciding to build or to retrofit susceptible buildings to be less susceptible to fire with different roof coverings and siding, and even like the first few feet around the house is asset hardening. So everything fits onto that model. And then the 4-box model is really nice. It's got all the parts that we need, but it doesn't fit on a triangle. And as you guys all know, the only thing that we know in fire to do is to make everything fit on a triangle. So that was really easy because the exposure one, like I've said, is inherent. So if you take that one off and you put likelihood and intensity as the two hazard portions of risk, and then susceptibility, we can put it onto this risk triangle, which I think I first did this in 2006. And then the other thing that we did here, I think this is in the GCHR 315, is that we rearranged Mark's equation a little bit. And we separated the burn probability from the flame length probability. And that's why we can now point to the likelihood of fire occurring and the intensity of the fire, if it could, the flame length probability. Mark had them together into the probability of fire given intensity classes. It simply turns out that there's an awful lot of power in doing it this way that I didn't realize when we started. But this portion of, let me see if I can, that portion of the equation is the impact. So we have probability and consequence now. We have the conditional impact, or we sometimes call it the conditional net value change. It's the effects of fire if one should occur, and separate from the likelihood of that fire occurring. It turns out, a lot of power to doing that. Okay, so now I'll give you a bit of a background on the actual Montana risk assessment project, and then Matt actually gave you quite a bit of this background. So the scoping for the project was just over a year ago, in the spring of 2019, when we were looking at what they needed to have done, when they needed to have it done is important. And then my records had it was under contract in June of 2019. And Matt mentioned these exact things. This is actually the image here is our roadmap for how to conduct a landscape scale risk assessment. And so we start here, and we did this last October with a field calibration workshop. You know, you can grab Landfire is a fantastic resource for vegetation and fuel data off the shelf. It's a great resource. But we have found that it's been always useful to calibrate the Landfire data to local conditions or with local input. Usually you don't change a lot of the rules, but the rules that you change are important, and then the folks who are going to use this have more faith in it because they were able to at least critique what was in there and provide some feedback. It also allows us to eliminate seam lines that sometimes exist in the Landfire data. So we'll talk about some of those things a little bit later on this morning. So we held that in Bozeman in October of 2019. In Missoula in November of 2019, we met and talked about which resources and assets we would be able to assess. And December, just a month later, we had the response function workshop. And then, like Matt said, it was just in February of this year that we had our relative importance workshop. And then we've been cranking ever since then on the effects analysis. And are right now delivering the final products. So basically June to April, so less than 1 year, is about twice as fast as we would normally like to do these projects because we have a lot of them going on. But you get a lot of attention when you're working in your home state. So that's how we were able to get that done. So a little bit of a background now on the assessment and what we call our landscape zones. So what Montana needed, obviously, was to have valid risk results in the state of Montana. And then what we do usually is buffer off of that a little bit. I think this is a 10-kilometer buffer around Montana into the surrounding states. And we simply want to make sure that we have valid hazard results, not just right to our border, but even beyond it, so that we can see a little bit of the context of what's going on right outside of the border. And then we buffer off of that for what we call the fire occurrence area. And that's simply because we need to account for the fact that fires can start in this area and burn into our analysis area. So we have to be able to ignite simulated fires here and have them spread in. That's what makes it how we get valid results here, is by allowing fires to start here and spread in. And then we have one more buffered zone off of that, and that's our LCP extent, or Fuelscape extent. And that one is a bit much, but that's simply that if we ignite a fire in the outer edge of this fire occurrence area, and if it were to run into the edge of the Fuelscape and stop artificially, that would affect our fire size distribution when we're simulating, and it could affect how we calibrated the FSIM model. And so we simply decided to, we do all of our projects this way, as a 30-kilometer minimum buffer off of the analysis area, and then another 30 kilometers for our Fuelscape area. So we've developed fuel data for the whole state of Montana, plus a 10K, plus a 30K, plus another 30K buffer. Okay, so I'll talk now about Fuelscape calibration. And I mentioned that we base all of our work off of Landfire data. When we first started the Montana project, the Landfire remap data through so 2.0.0 was available for almost all the state except for the Northeast, because that was in, I think, the North Central geographic area for Landfire. But luckily they produced the Northeast, or that next geographic area. So we eventually have remap data for the whole state of Montana that served as the foundation for the assessment. And then, this is my fault, but we we decided to do things a little bit differently than what how the Landfire Fuels team was working with the new remap data. And I think April Bruff and Jim Napoli put this flow chart together to convince me to not do it. They're like, look at how much work it's going to be to do what I was asking them to do. And I wasn't daunted because I didn't have to do it myself. But I don't want you to try to read and understand this, but to know that we did more or less reinvent the wheel to get what we think is a small improvement over the Landfire process, but it's a huge amount of work. And so then we actually, that's just separate from calibration itself. That's just sort of the foundational methods. And then for calibration, when we have these workshops, what we show up actually with in the background here is some spatial fire modeling with either Flam Map or this is with Nexus to show what are the implications of the interim fuelscape, the uncalibrated fuelscape. And so we have that map, and then we take that map and summarize that into the different fuel rules that we're going to be reviewing at a workshop. We can put some of those rules into Nexus itself and see how the fire behavior changes. What's the torching index? What's the crowning index? How does that fit with reality? That's what the local specialists tell us. And then we often use that compare models for a spreadsheet, which has been around for, I don't know what, probably 15 years. Yeah, about as long as the field models have. And we use those to critique and edit these fuel rules. And then, so what we have here is a depiction of a fuel rule spatially. I mean, it's just in a spreadsheet, not spatially on a map, but a fuel rule is a combination of vegetation cover and vegetation height. And it's the rule that we tell the Landfire rules are saying, if you get into a combination of this cover and this height, this is the surface fuel model to use, or it's this one, or it's this one over here. And we simply, that exists in a database, but we started trying to make it more visual so that it was easier to see how the rule was actually being applied. And then that's been a great help. And then you also have to have those rules for different disturbances, fire disturbance. This is actually 1 to 5 years and 5 to 10 years, and then with different severities. And also there's also different types of treatment to show. And those all have their own rules. So when we go to the workshops, and then we actually bring these up and show these spreadsheets and use them to critique if there's something that we didn't like, the locals didn't like about how, for instance, how this map looked or how the summary looked. If usually the behavior was sometimes it was simply too low, then we would make an adjustment either to this table or to how the canopy characteristics are mapped. And then at that workshop, we got some really excellent feedback about burnable agriculture, especially wheat. This is especially true for northeastern Montana. And so what we were able to do to address that concern, because the Landfire data themselves had wheat as non-burnable. So not all agriculture is not burnable in Landfire, but some of it is. And wheat was one of those that was non-burnable. But there is some experience with wheat fields burning, sometimes as stubble and sometimes in this condition. And so what we were able to do was to use Cropscape data to identify wheat fields. And we turn that into a GR2 field model, but we gave it a custom field model number so that we could control other things about how the wheat fields are burning. And then we took some row crops and did the same thing. We don't have a lot of row crops mapped in Montana. A fair amount of wheat there is, yes. I made that custom GR1. Those don't have any canopy characteristics. But the reason for giving it the custom field model is that when we ran FSIM, we were able to let those ag fields burn only during the driest ERC conditions. And we know that's not exactly right, that it can burn based on the time of the year outside of the driest ERC conditions, but this at least allowed us to make it not as available as other areas of landscape that are available to burn longer time period during the year. And then we did one other thing. They didn't ask about this, but it's where everybody with spatial fire modeling has been needing to go in the last, well, it's been obvious in the last couple of years, and it's been needed for a while, and that is that our urban areas mapped in Landfire and in other land cover classifications like the NLCD, National Land Cover Database dataset, they show them as being non-burnable because it's not a wildland fuel, and that's not incorrect. It's not wildland fuel. It doesn't burn like wildland fuel, so we shouldn't try to simulate that in our models. And yet, things like this, neighborhoods burning that are not wildland fuels, is something that we simply can't ignore. And so what we ended up doing was developing some not custom fuel models, but like for the ag, a custom TL9. So it's fuel model timber litter 9, but with a custom fuel model number, and a custom TL3. So again, a custom fuel model number, but just the characteristics of TL3. And we use those again so that we can make them burn only during the driest ERC conditions, the 97th percentile ERC and above. And we applied this custom TL9 with very specific canopy characteristics to what Landfire and NLCD had mapped as low and medium intensity development. But high intensity is still non-burnable. I don't think there's any high intensity even in Missoula. There might be some in Billings. There might be some in Missoula, but it's like, you know, downtown Seattle, maybe downtown Spokane are just those in those very highest. But low and medium intensity, there's quite a lot of in our cities in Montana. So we simply made it possible for our simulated wildfires to sometimes keep burning into these urban areas only during the very driest conditions, and we allow these ignitions to spread into these urban areas, but when we do our fire modeling, fires can't originate from there. So it's just the barest first step at addressing this issue, but we've at least taken that step. Okay, and then, so this is sort of how the overview of how the Landfire works is now we have this existing vegetation type across the state. This is all with the new remap data. We also have vegetation cover, vegetation height, and this is whether it's grass, shrub, or tree life form. And then we also have what's called the FDIS for fuel disturbance, which is largely wildfires. So some of those big footprints are wildfires that took place between 2010 and 2019. But also logging activities, field treatments, prescribed burns, insects and disease, wind throw. There's not as much wind throw and things like that because they're not as well known. They're not mapped as well. But we have to use this to update what Landfire, the veg team, thought was there. And from all that information, we now can produce fuel grids. So canopy base height, canopy bulk density, which is related to cover, forest canopy cover. So where it's gray, these areas that are in gray are obviously that's the grasslands and grass shrub and croplands and things like that where there is no forest canopy. Forest canopy height, and you put all that together and you get a surface fuel model map. And this one actually is just to a fuel type group: grass, grass shrub, timber understory, timber litter, and so on. So that's one of the main outputs there. And then one thing that you'll notice right now is, so this is our Fuelscape boundary. That's Pend Oreille, Lake Pend Oreille there. It's way out from the Montana border, and you saw that we actually wanted to go into Canada as well, and that doesn't work with the land fire way of doing things. But what we did was use some Canadian veg data. Well, actually, it's North American veg data. So we use that in that little portion of Canada with a very, very simple crosswalk from the very coarse veg type into fuel characteristics. And that was simply because it was better to be really, really general than to not do it at all. Not doing it at all implies that there's nothing there and it's non-burnable. It's a parking lot and fires can't start or spread across the border. Okay, so that's how we got the Canadian fuels up there. So, wildfire simulation. For the state of Montana, we used two different processes. One, the main one was the FSIM large fire simulator, where we calibrated the model to the historical occurrence from 1992 to 2017. And we ran the state at 120 meter resolution with a minimum of 10,000 iterations. So 10,000 whole fire seasons at a time. And in a few cases, I think we did 20,000 if there were not a lot of fires. And then we also ran FLEPGen, which is a fire modeling process that's really just based on flam map. It's a way to take anywhere from half a dozen to a couple hundred flam map runs and weight them together to account for different wind speeds, wind directions, moisture contents, but also account for heading, flanking, and backing, which is what FSIM does as well inherently. But it does it deterministically, and you can run it at a finer resolution, and you actually can make pretty good intensity maps. This is the way to get the intensity. So for wildfire simulation, again, not surprisingly, right? Mark in 2005 wrote the definition or measure of wildfire risk that needed probabilities of fire and probabilities of fire different intensities. And then it was about 6 years later when this paper came out that Mark wrote with his colleagues at the fire lab in Missoula, where he actually developed this system to predict or to simulate those things. This is the paper that describes FSIM. And then a number of years, probably almost 10 years, 5 or 10 years after that, this is the closest thing to a user guide. It's just a best practices guide for running FSIM. And then there is a paper out about FLEPGen, the concepts of it and the math and the equations behind it. It's being published in the proceedings of, was it the large fire conference that was held in Missoula? And that was just under 2 years ago now, and I think it's still not out. But you can get that from our website actually, if you wanted to read about that. So FSIM and FLEPGen. FLEPGen again is really just a ton of flam map runs. Then in order to simulate fire across an area, a state as large as Montana, you need to divide it into smaller pieces. And Karen Short and her colleagues call those different pieces pyromes. And we simply have called them fire occurrence areas or FOAs, but they're very similar concepts. And their area, a pyrome or a FOA, is an area of relatively uniform fire weather, fire climate, and fire occurrence. And you have to take that relatively with a grain of salt, because obviously there's a huge amount of variability in climate and occurrence within these. But they do more or less have to be spatially contiguous. So these are, I think it's 11 FOAs, fire occurrence areas across the state of Montana that we parameterize FSIM and calibrate the model to the historical occurrence within each one of these. And then after we do that each one, then we mosaic them back together into the coherent result. The inputs that we need for wildfire simulation: one, the Fuelscape, right? So the fuel weather topography, and then stuff about ignition. So the Fuelscape, which we talked about already in a fair amount of detail. And then you have to have the topography, the slope aspect, and elevation. So this is what often gets called the grid sandwich. This image I'm showing you here, I know Mark Finney drew this, and I think it might have been over 20 years ago that he drew that grid sandwich, and we're still using it today. It's crazy. We need to know about weather in each of these FOAs, and within each FOA, we have to characterize the distribution of wind speeds and wind directions, and we use RAWS data to do that. And Kevin Vogler at Pyrologix does that initial RAWS selection. We put some information together, and then we actually reviewed that at our October workshop in Bozeman and made a couple of slight adjustments if we can find a better RAWS station. But we use the RAWS for winds, and then for fuel moisture, well, for ERCs especially, which are important for FSIM, is we use Matt Jolly's gridded historical ERC data that goes way back long before we need it, but we use it from up to the fire occurrence database. And then Isaac Grenfeld, the Fire Lab, produced gridded simulated data based on those. So that's a way to have historical ERC data and simulated ERC data across the whole state without having to rely on just the RAWS locations. And then we need to have information about ignitions, ignition frequency and ignition density. So the frequency, really what that boils down to is what is the likelihood of a large fire ignition in relation to ERC for fuel model G within one of each pyro. And so we use Karen Short's fire occurrence database for the ignitions. We use Matt Jolly's ERCs for the gridded ERCs for the ERC database, and then we use some scripts and spreadsheets to compile that into some information about ignition frequency and to parameterize this equation here for use in FSIM, the logistic regression coefficients for the likelihood of a large fire day. And here, when I say large fire, what we use, the threshold is 100 hectares, which is a 247.1 acres, so about 250 acres. And anything below that, very little of our landscape burns in fires less than 250 acres in size. There are a lot of them, and they require a lot of attention for initial attack, but they don't end up resulting in much area burned because they're so small. So that's why we don't have to simulate the small fires with FSIM to get a burn probability. And then we need to know about ignition density because so within each of those FOAs, we have the model to tell us how many fires to put down in a year, but not where. And it's not a good idea to say that, oh, it's just spatially uniform, because as you can see here, this is a large fire ignition density grid where spatially the number of fires varies considerably. And we actually, the way this data gets used, it only gets used within a fire occurrence area, because this particular map has kind of both, has the number, the frequency and the density kind of in one number, but we only end up using the density part of that. And then for simulation, it's not very exciting, except to me, and I can actually, if I weren't wearing headphones right now, I could hear these things running in my basement about 50 feet from me. This is what we use to run FSIM, and well, it has to be a world's first, because I don't think very few people run FSIM, but we are solar powered fire modeling that this solar array here is more or less just enough to power these computers if they were running more or less 20, full speed year round. They actually consume a lot of power. Okay, and then here's our fire occurrence areas again. And then what we do to calibrate FSIM is to look at what the ignition frequency that I had talked about before. Ignition frequency and So that's like the number of large fires per million acres. We normalize it to size so that we can compare different FOAs at different sizes, and the average large fire size. And the dark dot there right in the center, that's the actual historical mean. And then we put the boxes around it for confidence intervals about how confident we are that the true average is in there. And then we also show what the 10-year, the most recent 10 years looks like, somewhere along that line. And we use that information when we're calibrating FSIM. Look, if you were to just run FSIM out of the box, you're probably going to get an answer that's way up here. It often has too few fires and they're way too big. And so calibrating FSIM is really about thoughtfully adjusting the inputs so that we're down within our confidence interval. We don't have to put it right on top of the historical average, but we certainly can. We can dial it that precisely. Okay, so that is the fire modeling part, and now got to talk about characterizing the highly valued resources and assets, which is really 3 parts that goes with our 3 workshops. Selecting the HVRAs, the NVC functions or response functions as we call them sometimes, and then their relative importance. So for selecting HVRA, here we have some common assets that get included. Communication sites, so this is obviously a very high value communication site that is not in Montana. Housing, but also other buildings are often included. Guard stations and backcountry cabins, things like that if we're working with a federal land management agency. Electric power transmission is almost always included. And then with a lot of our federal risk assessments, we often include recreation infrastructure. So those are some assets that sometimes get included, at least they get considered. And then for resources, obviously wildlife habitat, timber resources, water resources, whether it's for drinking water or for fisheries. And then there's like this catch-all for often gets called diverse and resilient vegetation, or like where, well, fire obviously is beneficial to a great number of vegetation types in the landscape. And so those often get considered. And so that's the HVRA selection, and we'll talk again about what we ended up doing in Montana shortly. HVRA selection, and then we have to have these net value change functions, these loss functions, and or response functions, if you want to consider beneficial effects. But that's this part of the equation, the susceptibility part, benefits minus losses, that's net value change. So the MVC functions are really, really simple. The function is maybe a misnomer because it's the way that we're doing it right now is simply a lookup table to inputs, simple inputs based on the fire intensity classes. So 0 to 2 foot flames, 2 to 4, 4 to 6, 6 to 8, 8 to 12 foot, and then 12 foot plus. So with the fire modeling, we have an idea of how likely for any point on the landscape, based on what the fuel characteristics are and the weather is there, we know how likely these different, well, we have an estimate of how likely these flame length probabilities are. That's the flame length probability. And then we have to say, well, what happens because of that? And so here's an example of a generic HVRA, this HVRA2, that is neutral at low intensities and then becomes more negative. So the negative number meaning that it's an adverse change. It's not a benefit, it's an adverse change that's more negative. And then here's another hypothetical HVRA that is not even neutral at the bottom end, right? So it's never even neutral. Even low intensity fire can damage this. These are both good for most assets, will work that way. And then the last part of HVRA characterization is relative importance. And the reason, what Mark is showing us here, this is the reason we use this term relative importance workshop and how we call it that. So what Mark said is that you really, if you want to add different resources and assets together, you have to do it with a common currency. So this equation is inherently adding up the J we're inherently adding them up. And it's assuming, the equation assumes that they're on a common currency. So you can't have, you know, square footage of houses or number of houses or dollar value of houses with acres of sage grouse habitat, because those are not on a common currency. So we have to do this though. It's really challenging, and we think we kind of don't want to do this, but the Canadian band Rush, who lost their drummer just in the last few months, Neil Peart, Rush in their song Free Will tells us why we have to do this. Because as they said, if you choose not to decide, you still have made a choice. What I just said is not what the lyrics say. It's what you actually hear when you listen to the song. They wrote it a little bit differently, but there's the idea. If we decided not to decide which of these things was more important than the other, or how their relative importance varied, we've made a decision. And that decision is that they were equally important. And equal importance is not what any one of our dozen or more risk assessments has ever come anywhere close to settling on. So we can't not do this, the importance part, but we have ways to do it. We've always gotten through this part, and we did it very successfully in Missoula just a couple of months ago. And then, so for the Montana assessment, we had, again, the 3 workshops for selection, the MVC functions, and the relative importance. We ultimately focused in the selection on people, wildfire threat to people, their houses, but really their houses, their buildings, the schools, the hospitals, so all the structures, residential, commercial structures, the critical infrastructure that we use every day, so our communication sites and our electric power transmission, and surface drinking water. Not the groundwater, because the groundwater isn't negatively affected by fire. But the surface drinking water definitely can. And we considered strongly including things like timber and teeny habitat and lots of other resources. Very, very good conversations. They were ultimately not included, in part to keep it focused on people, so that there was a really common interpretable theme to the set of HVRAs, but also we did not have a lot of time to get this project done by right now, and so we kept our focus on just on those things. At the relative importance workshop, which was again excellent, and looked at a good discussion about how to allocate landscape importance to these different resources and assets, and this is how we ended up. That all of our structures, residential, commercial, industrial, everything all put together, has about 60% of the overall importance. The infrastructure, 25%, and the surface drinking water, 15%. And you have to keep in mind for surface drinking water, and I'll have the actual number later, I think it's about 1/3 of the population of Montana is served by surface drinking water. So if we were all served by it, that would probably be a larger piece of the pie. But we're not all served by it, so it's maybe not quite as big as you might be thinking. So now I'll show you some details on those 3 broad HVRAs. So Montana structures. This is a landmark risk assessment in terms of the quality of the data layer that we're using for this. We often have to use, it was called Whipple, where people live, Landscan based, rough estimates of where people might be living, but that didn't include commercial buildings or anything like that. But Montana has a fantastic database of structures across the state. And what we had to do, so this is all of them, and I can't remember if it's, I don't remember how many, 500,000? We ended up having to categorize them into different relative importance themselves, different importance classes. So the most important structures were correctional facilities, multifamily housing, health and medical facilities, nursing homes and daycares and things like that. Then the next level down was single family residences, outpatient clinics, schools. Then we had most commercial buildings just fit in this class 3. If there was no information at all about a structure, we put it in class 2. And then the lowest class was things like rest stops, storage structure, parks and rec areas. We decided to include everything, but they don't all have the same importance. And then up here, the very top, you can see the response function that was applied. And actually, this was a departure from previous response functions that we had used, and that the local specialists at our workshop suggested that we split out the response function by the fuel type. So the grass and sagebrush fuels have a different response function than the taller shrub and tree, largely to account for that there's likely to be more spotting and embers from the taller shrub and trees than there are from the grass and sagebrush. So they're slightly different response functions. And one thing you'll notice is, get the pen out, FIL1 is the lowest intensity level, so just 0 to 2 foot flames, but those are not 0. We're not saying that there's no risk to a house for low intensity fire if the fire backs in there, because that's a reality. That happens quite often, that an unattended structure, even if it encounters low intensity, can burn depending on the level of defensibility of the house, or how much continuity there is between the wildland fuel and the house itself. And at the other end as well, the very, very highest intensities, these are 12 foot plus flames. Often with crown fires, they're going to be, could be 100 foot flames. But you notice that those do not go all the way to minus 100, because we do know that some of these houses and structures do survive in these conditions, especially if they've been well defended. So we took care to not go all the way to 0 and not go to all the way to 100. And then we gave a little bit more negative values to the tree and shrub than the grass and sagebrush. So those, what we're looking at are the points right now, but then to do our risk calcs, we have to do it all from a raster world. And so we ended up making a raster of structure importance. So if it's at 30 meters, well, with a little bit of smoothing. So if there's a really tight cluster of a number of houses, they would all add together. So here's the structure importance raster for the state of Montana. Okay, the next HRA we looked at was critical infrastructure. It's the electric power transmission. We had acknowledged 2 types. One, the low voltage, which are most likely to be wooden poles, and then the one very high voltage line that runs out through the state. That one we gave the high voltage bigger than 345 is a much milder response function. And this was after talking with a lot of the DNRC folks who are type 1 and type 2 ICs, and division soups who spend a lot of time on managing fires both within the state and outside of it, saying that, yeah, we can underburn that thing, and it doesn't do any harm or damage, and they sometimes don't even have to de-energize the big one. And then the wooden pole ones, though, are a very clear acknowledged issue in the state, and so that response function is quite a bit more negative. And they do go to minus 100 because the wooden poles are very, very easily damaged in fires. Then we have critical, not even critical, just all communication sites, actually. We don't have enough data to tell us which of these might be the most critical. So it's just all communication sites. And another response function also broken out by tree, shrub versus grass and sagebrush, but with, unlike the other structures, with some allowance for that low intensity fires might not damage these whatsoever. So a lot of thought and experience went into those response functions. And then the last one, H4A, is surface drinking water, which we actually used a method that was pioneered for the Northern Region risk assessment, and the method was suggested by the Northern Region hydrologist and water resources people. And what they actually did was erosion modeling under comparing, they did no fire, low severity fire, and high severity fire. And then by saying, well, the difference between low severity and no fire is the effect of low severity fire. And the difference in erosion between high severity and no fire is the effect of high severity fire. And with that process, we were able to make a response function that varied spatially across the landscape that was sensitive to both fire severity, which we get from the fire modeling, and erodibility, so the soil erosion potential across the landscape, soil type, slope steepness, all that stuff. And then what we did was said, well, if it was a grassland, a cropland, or a wetland, that's just we just use the low severity effect, no matter, so that's just the probability and the low severity response function. And then in the forest and shrub settings, we use the high severity response for the FILs 4 through 6, so which is 0 to 2, 2 to 3, 3 to 4. So 4-foot flames and above, 4 to 6. 6-foot flames and above, and then below was the low intensity, low severity. And then what we're looking at is actually an importance raster. So we know where the intakes are and the basin that serves that intake, and that it's worse to have fire that is closer to the intake. And we know how many people are served by the intake. And we use all of that together, information together, to get how important different parts of the landscape are for surface drinking water. And you'll see that it covers everything. So then we have effects analysis, which is really about applying this equation for everything that we just looked at. And the other part of effects analysis that we're just wrapping up right now is writing it all up into, a lot of these are, reports like we're producing for this project. Some of them are data. So the research data archive, if we publish data there, and with our colleagues at the Forest Service with peer-reviewed journal articles sometimes. So the effects analysis is really where you get to that level. Okay. So far, I've been talking a lot about the innards of a clock and how it all puts together and all that stuff. And now it's time to switch over, and just all you wanted to know was what time it was. You want to see maps of where the hazard and risk is. And look at that, it's 10:13, and this clock says we're about 5 minutes behind schedule now. That says it's 10:08. So we're good. We're talking about actual results now. Okay, hazard results. So here's our burn probability for the whole state. Now recall, we did this in 11 different parts, then pieced them back together. And I know I can't find those different parts. We've taken great pains to make sure that everything integrates perfectly. So this is the likelihood of fire across the entire state. And we've got everywhere from very low probabilities of fire, where it's either non-burnable cropland or the lakes and stuff like that. Almost everything else has at least a 1 in 10,000 chance of burning per year. But all the way up to in the Frank Church area, that's well above a 1% chance of burning per year, and that up to 4.5% chance, because as we all know, there's a lot of fire over the hill. That's just outside and near the Idaho border there. So that's our burn probability result across the state. And then mean flame length. This one comes from our FLEPGen. You get a very, very similar one out of FSIM. And a couple of the things that you'll notice are fire footprints. So this is one of our fires. I forget the name of that one, right? That are burned in, that they may not affect the probability of fire that much, but they definitely affect intensity. I think that's Rice Ridge by Seeley Lake. Can't quite see it in the flame length, but there's the Lolo Peak fire, sorry. So all these really, really recent fires, they show up. They can show up both in the flame length and in the burn probability results. And then we took mostly the flame length results and applied a process, an index called suppression difficulty index that was first developed in Spain, but then Kit O'Connor with some other colleagues in Missoula took that on and made it spatial and we've actually produced SDI maps for the whole Western US. But we decided to make an SDI map here for Montana because one of the things that you need for SDI is that intensity. The intensity is sensitive to the Fuelscape, and we just gave them a better Fuelscape. So, but it also has, so it's got the fuel conditions, which are custom for Montana, but it also has things like the slope steepness and then road and trail access. So this is a product that you have available. That's at 30 meters across the whole state. And then another kind of a cool one that we do, is we've called it different things, and we actually pioneered this concept in Western Montana 4 or 5 years, well, maybe it was 3 or 4 years ago. We were calling it hazard in context. We've called it hazard to potential structures. It's right now risk to potential structures or risk to homes. But here's what we did, is here's the response function that we had for houses. And in our regular risk assessment, we only applied that result where the structures existed. And so all you could see is, well, there's risk where the structures are, but where somebody might be considering buying or building a structure, what if we were to go there? What's about that? So all we did was apply this response function everywhere across the landscape. And so it's got the risk to potential structures. It has burn probability in it. And then it's got flame length probability and the net value change, the NVC function. That's all this is. And so really it's a way to integrate burn probability and fire intensity, those two parts of hazard, into one map. So it's really kind of a hazard map across Montana, but it's a hazard largely with respect to structures because we have that response function here. And then we also know, of course, where the houses are, where the structures are. And it's kind of an interesting thing. Maybe it's a chicken and egg thing that if I flip back and forth, generally speaking, the structures in Montana, they're in the least locally the least risky, least hazardous parts of the landscape. And that's in part because building development reduces fire to a certain extent, and it's also where our greatest fire suppression resources are, and we have a lot of reason to keep fires out of those places. But we're not randomly putting fires into the middle of or structures into the middle of a bob, which would be extremely hazardous. Okay, so that was some hazard results, and now we're going to talk about some of the other risk results. And here is the raster version of our main result. And it's a little bit splotchy looking because of the watersheds, the surface drinking water, and how important that is relative to other things in Montana. And it makes it really, really hard. Well, I'm going to point out on the legend here that each of these classes is a tenfold decrease, right? So we're increasing risk this direction. So it's a tenfold decrease, each order of magnitude. So this is a huge variation across the landscape here. But that makes it really, really hard to interpret at the pixel level. So one of the things that we do is summarize those pixels to different zones. And what we've done here is use 6th level watersheds or 12-digit HUCs, hydrologic units, and said, here's the average risk, average expected annual net value change, expected risk within each one of those watersheds. And this is a far better way to visualize because it kind of spreads that stuff around, and you don't get as much variation when you're grouping things like this. And then I'm going to use this as the background now to show the counties and across Montana and how they rank in terms of overall risk. And this one that I'm showing is the average. So number 1 is Ravalli County. So the average risk, the density of risk to all 3 of those HVRAs, so to water, to structures, and to critical infrastructure, is the highest in Ravalli County. and then Gallatin's number 2, Missoula's number 3, and so on. And so that's all the HVRA together. Then people and property is fairly similar. Infrastructure by itself. So that moved around. So now Missoula is number 1 just for infrastructure by itself. But one of the things that you'll notice is that in southern Montana, we've picked up a bunch of counties grouped there that apparently have a lot of transmission infrastructure that has a significant amount of threat. And then the surface drinking water. And we're going to show you a little bit later on another way a more focused way to look at the surface drinking water. So these tables, these are all tabulated in our report, so you can see how they rank out and even their absolute numbers about how they are relative to one another. And now, of risk. This is related to this concept of risk transmission, that fires can start one place, but they spread and they can cause effects someplace else. So looking at just the surface drinking water, these are source locations of wildfire risk to surface drinking water. And now this is a nice map to look at, even though it was still based on just that EMBC for water. But what you can start to see is like, well, why is it that this area here is a high source location of risk? And it's because those fires that start there are starting in and very near Bozeman's watershed. And then the Helena watershed, the 10-mile watershed, is in here, and then Columbia Falls, their watershed. So this is telling us where across the landscape can fires start and do a lot of, confer a lot of damage to potential damage to drinking water, watersheds. So that's drinking water. The next one is infrastructure. And so this is infrastructure by itself. And so this is, where we have the infrastructure, where do fires start and reach it? If you're in the lower classes, it's simply that you're far enough away, both from a fire spread distance, because either the fuel or the weather makes it hard for fires to get to some transmission infrastructure. And then the last one is the people and property. And these are all in slightly different places, but not so much. And then lastly, we can put them all together and say this is the annual risk source to all highly valued resources and assets. So it's where do fires start that can cause some damage to structures, surface drinking water, or critical infrastructure. So you see in Western Montana, there's not a lot of places where you don't have to think at all about this stuff. Fires can start almost anywhere in Western Montana and reach something at some time, which is why we do fire management. Okay, and now the last couple of things that I'm going to talk about, I probably have another 10 minutes, 10 or 15 minutes of material prepared. I'll talk about risk to surface drinking water systems, and then we're going to talk about risk to communities, which is to structures and communities. So this is the method that was included in the overall assessment, but we're gonna summarize it by surface drinking water supply system, public water supply system, of which there were 54 across the state. Again, the pioneering work we did for the northern region just a couple of years ago. So it's got all the kinds of cool stuff in it about the erosion modeling and stuff. And I think the erosion modeling was done by RSAC or GTAC, the Forest Service GIS shop down outside of Salt Lake. And again, I think I mentioned this earlier, was that surface drinking water supplies water to about 1/3 of Montanans. The rest of it is from groundwater, like in Missoula, it's all groundwater. Okay, now our base map here is just the burn probability, but we can't show the erosion potential, stuff like that. But if you just look at the average risk within a watershed, what this highlights here are the watersheds that they might be small and they're in relatively high hazard locations. So high probability of fire and or high erosion potential. But maybe they don't necessarily have to, well, they might serve a lot of people. But I think what gets highlighted when you look at this, most of these are really quite small systems. And they're all mostly in the western part of the state, because that's where the probabilities are the highest. So like, you might look at this and go, okay, well, Logan Pass, number 9, it only serves in the summer, and we probably have overestimated the fire probability up there if it's that high on the list. But looking at Pinesdale, it is in a very high hazard location. It might not serve a lot of people, but that's certainly something to look at. And then Bozeman shows up. But then another way, and equally or maybe arguably more important way to look at it, is the total risk for each public water supply, which is going to include how many people it serves. And so when you look at it that way, Bozeman's watershed comes up to number 1, and the Bozeman watershed itself serves 26% of the people in Montana who are served by surface drinking water. And so it's in a relatively high hazard location, and it serves a lot of people. So it's number 1 in the cumulative. Billings is probably a lot. It serves a lot of people as well, and it's in a moderately. It's not the actual drainage is the basin is not just near Billings, right? They serve a broader area. The Helena watershed shows up, and also the Butte Silverboro watershed. So this is another way to look at. Those are two different good ways to look at individual public drinking or water systems. Okay, and now again to talk specifically about risk to structures by themselves, not outside of the context of adding all 3 of those together, and to summarize it by counties and by communities. So again, there's where the structures are across the state, and the next couple of questions that somebody has is like, okay, well, how would you accumulate that? How do you average it out, and where is the risk the highest? And so here is the county summary by average. So this is pick a structure at random. Doesn't matter how many are in the county. Doesn't matter if there's a lot or a few. But on average, how is their risk from that RPS, the risk to potential structures? So it's not the average of everything you see in here, because there's that lot of red. It's the average where those structures are actually existing. Okay, so Ravalli, number 1. On average, the structures in Ravalli County have a lot of likelihood. Here's Ravalli right here on the scatter plot. It's got the most likelihood, and not the most conditional risk, which would be that it's in timbered areas, but quite a lot of it. And so it ends up being number 1. Granite County, number 2. Lincoln, mostly because in Lincoln County, most of the people are actually right here in Eureka and outside of Eureka. Mineral County, people are scattered all over, but they're in relatively high hazard locations. So that's on average. And then the next one is in total. So this is basically take the on average number and multiply it by how many structures, or the total structure importance within the county. And Ravalli County is still number 1 because it was not a low population, or there's still quite a fair amount of structure importance in Ravalli County. So it's high on average, it's high in total. Some of the other ones have moved around a little bit, but they're still, Missoula went up to number 2 because it's more moderate in terms of the risk to potential structures, but it has a lot of structures. And so that's people ask all the time, very good question. How do you use the difference between the average and the total? The average risk is usually good for prioritization, which counties might you want to go look at first, and then the total is useful for allocating resources. So you might end up with a high, like Mineral County being number 4 is fairly high on the list. It might need some attention, but it doesn't have a lot of people. And so it's not as high on the total list, and so it doesn't even show up in the top 10. It might not need a lot of resources. So prioritization versus allocation. Okay, so that's by county. These tables and graphs are in the report. And then what we also did was summarize by communities. And there are 361 or 2 communities across the state. And this is how they were defined. It was US Census populated places across the state. And a populated place are all the cities and towns, every incorporated city and town, and what are called census designated places, CDPs, 361 across Montana. And what you can see here is that other than, these are actually Butte, Silver Bow, and the Anaconda Deer Lodge they're actually nationwide exceptions. Most of these communities are quite small. And if you look at this map for the whole country, you can find Butte because those polygons stick out, where they're technically, they are incorporated places because the whole county is kind of incorporated. That's why they're so big. Okay, but that is just really small areas, right? Some of those CDPs, is that Pinesdale probably, Corvallis, Stevensville, Victor, right? So these are really small things. They're where the concentration of population is. But people live outside of those, and it's important to capture them. And so Alan Ager and Ken Bunzel, who both, Alan Ager works for Rocky Mountain Research Station, Ken Bunzel is in the private sector and has done this work for Alan, is developed a method of looking around those small, tiny things and assigned almost all the landscape to one of those communities by travel time. So they said, well, if you're not in one of these communities, but you're near one of them, which one should you be in? Well, you're in which one you're closest to by travel time, by drive time. And so that's what this is. It's the drive time up to 45 minutes. So what you can see is there are large parts of Montana, well, of course, the Bob Marshall, that are further than 45 minutes travel time to the nearest census designated place or city or town. But we're not concerned about that, and you'll see why in a sec. And then the other thing that we did, the last one, was to shrink that down to just the parts of those communities that actually had structures in them. So it's a concave hole around the structure points within each community. And this is why I'm not too worried about the fact that we're going to miss structures. So in these areas that are not assigned to a community, they only account for 1% of the total structure importance in the state. So it's not that they're not important, it's that we simply couldn't assign them to any one community because they're really not associated with one of those things. But overall, with the communities, we're actually capturing almost everything. And even though the cores of the communities are so small, they actually account for 66% of the population, or of the structure importance, because that's where the population is so concentrated. Okay, so now let's see, when we summarize risk to structures by community, what do we get? And again, here's the average. And not surprisingly, we're still looking in the Bitterroot Valley, in the southern Bitterroot, the populated southern Bitterroot Valley, because it's still where a lot of the hazard is. So number one, on average, so the structures in Connor are on average the most exposed to fire. They have the highest combination of likelihood and intensity. And then Darby and Sula, Charlos, Pinesdale, and then the only exceptions, right? We pick up Seeley Lake and Condon. And Seeley Lake, I should mention, this is after the Rice Ridge fire. The Rice Ridge fire, you can see that blob there of yellow in the risk to potential structures background reflects that the risk is actually lower now than it was before. We didn't do this before. We don't have the before those fires. So even after that, it's still a fairly exposed community. And then we pick up Eureka and Fortine up by the Canadian border There's just all the structures there happen to be in relatively high hazard locations within that county. And then here's the total. So that was on average, but then when you accumulate it, things are a little bit different. Oh yeah, and I forgot to mention that this is not just the community core, right? It's the core and the zone around it combined, those two combined. So now Hamilton comes up, and it's Hamilton. Here it is on the scatter plot, and it's not the highest in terms of risk to structures, like the overall, but it's got that middle ground combination of how much structure importance and how much the average structure importance is. And so Connor now is number 9. You see it here. It's the highest, and from the left to right, it's the highest. That's by the other measure on average. I mean, it was the highest, but it doesn't have that many people in it. But the fact that it still made the top 10 on both of those means that it's a place to look. The Southern Bitterroot, there's a lot going on. Whitefish now popped up, and another interesting one, number 2, was Big Sky, Montana. Because there is a lot of structure importance in Big Sky, and a fair amount of hazard as well. So again, if I go backwards, it's prioritization. These are the communities in this order, not just the top 10, but the whole entire list of communities that might need to be looked at for doing additional work. So prioritize which communities you look at, but then allocate resources in this way. So Connor needs a close look, but it may not need a ton of resources for mitigating risk because there's just not as many people there. Okay, we're going to get ahead of the questions and talk a little bit about a project called Wildfire Risk to Communities. The website is wildfirerisk.org, which just came out a week or two ago. And as you will see, it does very similar things to what I just showed you for communities and counties. And that's in large part because we at Pyrologix design the analysis for both. And it's a good way to summarize stuff. So at the wildfirerisk.org website, if you go to this explore page, and you can type in any state or county or community and zoom right into it. So this is the whole state of Montana. And what you're seeing here is a risk to potential structures map, risk to homes. The scatter plot shows you, it's actually the same scatter plots that I was just showing you. Theirs are way prettier than mine. But the likelihood of fire and the consequence of fire, and so you can see where Montana is relative to other states. Of course, there are states that are a lot worse, and then we're better than well, a few states that are a lot worse, but we're worse than most. I think we're the 86th percentile by states, which you can actually see in the actual app. So what's the difference between this result on the wildfirerisk.org and the one that I showed you? So everything in wildfirerisk.org was built from land. It was FSIM results that were done nationally at a 270 meter resolution, whereas ours was 120. It was done from Fuelscape, the Landfire version 2014. So it's more out of date, and it didn't have any local calibration in it. And so if you looked at both side by side, I didn't get slides together to look at that, you're going to see a huge amount of general agreement between this RPS map and the one that we have for Montana. But when you get into the Montana one, you'll see actually we have a fair amount more precision, and it's way more up to date. So that's the state level, and then here is the county level. And so I zoomed in on Ravalli County. If I were to hover over this in the app, it would tell me that Ravalli County is the highest county in their app. It's the county that has the highest average risk to structures within the county, even though it was done with different measures. So in the WRC project, we had to do this nationwide with one methodology. So we used land scan data about where population is distributed across the landscape, because we didn't have the structures data that we did in Montana. So even though the data sources are different, the concepts were very, very similar. We're getting the same answer that we had here. And then I think that even continues. Yeah, Connor came up as being the #1 most at risk on average community in Montana, in the WRC project as well. Now, when you get down the list, there lots of things are going to flip-flop, and the list will not match exactly. And what I would say about that is that the Montana assessment in our report is a far better one for Montana, simply because it's more up to date, had our local calibrations, and uses the structured database that we have. But the methods are essentially identical. Okay, I made it. I think now, Signe, I think we're ready to go and have Brian, I think, talk about the open data portal before we open it up to questions.
Yeah, thanks so much, Joe, for that presentation. That was awesome. We are going to switch over to Brian Collins with the DNRC. And Brian, I'll give you a second to queue up the screen there. And then after that, we'll move into a Q&A session. So Brian, I think you can go ahead whenever you're ready. We see your screen.
Perfect. Okay, great. That was my first question. Thanks, Joe. Wonderful presentation. I'm going to have to watch that many more times as we move through this process. Just a quick overview for the listeners in terms of the role of my team at DNRC. You know, our role collectively for our agency is to provide data and information. In the case of this project, to provide the data to the folks who want and need it. But really our responsibility is to help make this sort of information come alive. So there's been a couple sort of big questions that are already coming our way. We anticipated, and they make sense. One of them is, when do we get to see the report? And gladly, the answer is today. I think you can see on my screen there at the forefront of this website resource is a link, and I'll go through functionality here in just a minute of this web resource, but a link to the draft report that Joe has just finished presenting on. And then the follow-up to is, when can we get the data? And the answer to that particular question is soon. It's important. It's going to take us some time, but we're definitely focused and plan to be making continuous effort there. And to that end, I was just going to give some context of where we're at. My team, the Fire Protection Bureau, Forestry Division, our agency with this project, I started to say in sort of my talking points here that we're at the tip of the iceberg, but I quickly went into sort of a dad joke refinement to say that we're at the tip of the crown fire. I'll pause for some eye rolls there and assume everyone's laughing, or at least I can't hear you heckling me. But that's where we're really at the beginning of this process, having received this deliverable from Pyrologix. My team has a tremendous amount of fortune with the access that we have to the technological resources, especially web-based GIS resources. And I often have to remind myself that with this power comes great responsibility, because the web resources will be the primary delivery mechanism for this information. The layout, the design, the aesthetics, from my perspective, are as important really as this information is itself. And ironically, working from home, listening to a fair amount of music on YouTube, and being sort of barraged with various commercials, I keep getting these pop-ups for online class opportunities through the masterclass program. And one that keeps playing on my screen is a class from Neil deGrasse Tyson. And he makes this comment at the beginning of it, and it was really pertinent to where I found myself, because I'm so eager and excited about what we can do with this information that I need to remind myself and have others remind me that we do have to slow down and really start to digest this. But the comment is, one of the great challenges in this world is to know enough about a subject to think that you're right, but not know enough about the subject to know if you're wrong. And so at this point, I guess for today and what I'm going to demonstrate, what I know is that we have a tremendous amount of information, and it's going to take us time to digest and understand what all of this means and how we can use it. We do have, as Joe represented, a significant amount of data from a GIS standpoint, raster data, vector data, tabular data. Again, just a sort of a synopsis of some of the information, the fuels calibration raster data sets, the FSIM results with a custom Fuelscape, highly valued resources and assets characterizations, the various net value change data sets, burn probability, flame length, fire intensity, et cetera. And then what he touched upon there at the end was sort of this summary information, ranking communities at risk by county, census populated places, the community cores, the Alan Agar research areas of interest, et cetera. So there's a lot there, and we most certainly do intend to be moving forward, making that data both available and accessible to those that want to use it. What I'm going to do right now is just take a few minutes to simply walk you through this website resource that we've developed that will live on and sort of be the online representation or landing page for this data. And Signy, I believe, will be providing either in the links for the GoToWebinar here or follow-up communication URLs to the site and other resources of interest here. One thing I'd like to mention for this website and others is that there is slight differences in functionality between some different web browsers. So I'm going to do a quick demonstration just between Chrome and Firefox here. Really quick, it should be pretty straightforward and intuitive, but I'll just touch on that nonetheless. So the first thing that I'll draw your attention to again at the top of the page here is a link to the draft report document that Pyrologix has delivered. Right now I'm in the Chrome web browser. Chrome will actually display the document in the screen. It's not necessarily that accessible, but you can peruse it from this level if you like, download, print, etc. There's also a download button here if you want to obtain an actual copy, digital copy of that PDF file. The difference in Firefox when I click this link is that it does not display in the screen and immediately prompts me to download that PDF. So slight nuance, but just wanted to touch upon that. Return to the home screen. What I've done initially here is just drop a simple reference map into this interface that summarizes some of the characteristics of the structures data set by county. We do plan to add many more resources such as this to help people start to dive into these resources. This map is interactive, as one would expect for a map on a website in the year 2020. What I'm going to do here is click on Ravalli County. It returns a pop-up with some summaries of the types of structures within Ravalli County, total number of structures, some of the categories that Pyrologix utilized in their analysis and modeling efforts. If I zoom into Ravalli County here, and I will pick on Connor, since that was one of the talking points that Joe mentioned. So as we zoom in closer to any given community, the county borders disappear and the actual discrete structure point locations appear on the map. And again, for these, they've just got simple customized pop-ups so that you can see what kind of structure each of these points on the map is. Incidentally, this information is coming from map web service layer that's hosted by the Montana State Library, part of the Montana Spatial Data Infrastructure data sets, very rich source of GIS information for the state of Montana. So that's a quick overview of this map. Below that are just some initial resources. We have many, many more. And back to layout and design and aesthetics and making these resources meaningful and approachable. We just want to take time to make sure that the content that we're adding here is useful to end users. But just a few quick links here. DNRC Interactive Wildland Fire Map. Some of you may have heard of that. We've been supporting that particular resource for a number of years and had a lot of good feedback, and quite a large number of people utilize that. Web application that we developed a couple of years ago based on the Montana Community Wildfire Protection programs across the state. This is a link actually to a data set that we maintain at our agency. It's the Rural Fire District polygons. I'll just click on this really quickly. This allows an end user to do some cursory exploration of this data, but actually be able to download this data set. This is part of a larger initiative my team is working on to make data that our agency maintains more accessible to people that want or need that information. And then finally here at the bottom of this particular resource page, just a link to the website that Joe mentioned, the USDA Wildfire Risk to Communities. So this link will actually take you to that interface if you want to explore this information at a scale broader than the state of Montana. And then last but not least, at the bottom of the page is a link to request more information, be added to our mailing list, and provide any comments if or when you have those. So hopefully I didn't rush through that too quickly. I will turn it back over to Signe now. I think we'll move into question and answer phase of the webinar. Is that right, Signe?
Yeah, thanks, Brian, for that presentation. We're going to open it up for questions now. Some of you have already typed some in. Please feel free to continue to do so. Quickly, Julie is going to help guide us with some visuals during the Q&A and possibly do some ArcMap demo. So I'm going to go ahead and switch the screen over to Julie, and we'll just wait a second for that to queue up. And there we go. We've got Julie's screen. So you're on, Julie, and you're welcome to ask questions of any of our presenters. I'm going to go ahead and read some of the questions that we've got in the queue right now, and any of the panelists who are on the webinar right now can feel free to jump in and answer those. Julie, is there anything you wanted to go over ahead of time?
No, just you can see here on the screen that we have many of the results that Joe just presented available to review if those questions come up.
Okay, awesome. All right, I guess we'll go ahead and get started with some questions that popped up earlier in the presentation. And I think these first couple are fairly softball questions. So we had a question on how did you develop the fuel data for Canada? Seems probably appropriate for Julie or Joe.
Yeah, actually, I think the folks at Pyrologix who actually did that are not able to speak. They're not panelists. So the short answer is I don't remember. The longer answer is really just like I mentioned quickly in the presentation, that there's a North American database of vegetation type. It's very coarse. In that strip of land within 60 kilometers of the Montana border, there were probably only like 6 different veg types. No information about veg cover or anything else. So it's we simply took the veg type, picked a surface fuel model, a base height, a bulk density, a canopy cover, and mapped the whole thing. So it's very, very coarse. I wouldn't use it for anything except for what we did.
Okay, thanks, Joe. Another question, I think Brian started to get into this, but maybe we can just summarize that quickly. Is the structured data set in Montana open source data?
Sure, I'll take that one. Yes, it is in fact open source data. It's available from the Montana State Library GIS resources. Like I mentioned, it is one of many data sets that are included within the Montana Spatial Data Infrastructure, but it's accessible to anyone who wants to obtain that information, yes.
Okay, thanks, Brian. And I can post some of these links too on our past event webinar page once they're available, if that's helpful. Maybe I'll just post a link to that GIS library. Okay, and then another question dealing with GIS and scale. What is the scale that someone could drill this down to, so the meaningful pixel size? And I think you may have referenced that earlier in the presentation, but maybe we can review.
So we did the fire modeling. The fuel calibration was at 30 meters, the native land fire resolution cell size. The fire modeling was done at 120 meters. But then we put it through an upsampling process to bring it to 30 meters, but it's not true 30 meter data. So the right answer to that question is not all the way down to the 30 meters, which is about a 1/4 acre in size, but I couldn't tell you an exact number beyond that, but it's definitely more general than the 1/4 acre in size. Yeah. Julie, do you have anything to add to that?
No, I'd say that's about, I'd even caution against using it at the actual 30 meter, just because there's a lot of uncertainty in the underlying data, even at that level.
Great.
Okay, thank you. This next question is a little bit more detailed, so it might be more appropriate for a conversation via email, but can you quickly go over or let us know where you could find more detail on how you used travel time to derive the polygons? And if that's more appropriate to answer that via email, let me know and I'll connect the person who asked the question with one of you.
Okay, well, actually, and it's easy for me to answer because we did not do that. And so I'd have to connect somebody with Alan Ager and Ken Bunzel. It was Ken Bunzel who did the GIS programming to do that. But the travel time, I can say this, the travel time was based on a road network database that knew the speed limits on all the roads. It's pretty comprehensive. It had all kinds of roads, even down to some fairly small non-public roads. So they used the travel speed for each of the roads in there, and then they even had an overland speed so that that's how you can get an area. Otherwise, if you couldn't travel off of a road, there'd be no travel distance, whatever, off of that. So that's how it covered the whole thing. And then the actual programming is Ken Bunzel who did that stuff. So we can find a resource to link to, I think, for that.
Okay, great, thank you. We'll do some follow-up there. Okay, this is a good question. Can you show us data on where the firefighting resources are and where they're located and any probability as it relates to fire?
That's easy. No. So we don't have ourselves in Julie's map, we don't have the data on where firefighting resources are. And those are not an input, not a direct input to any of our fire modeling. They are an indirect input 2 or 3 times removed to the extent that that firefighting resources have influenced fire occurrence over the last 25 years. because if fire occurrence is influenced by fire suppression resources being concentrated in certain places, then that would influence the historical occurrence, and that would influence all of our inputs, and therefore it influence our outputs. But beyond that, we didn't use those data. So we simply don't have them to display.
Okay, thanks, Joe. Here's another question about, let's see, which layer is best for updating the WUI layer in the county?
So Julie, let's go ahead and put on our 30-meter RPS, I guess. And then speaking of WUI layers, the one of the better, well, actually there's a combination, right? And now that I asked you to put this on, I realized that's not what I wanted you to put on at all. But we've been pioneering some ways of making WUI layers based on different hazard and risk results and population results that that'll be interesting. And one of them is to look at whether houses or structures are on burnable land cover or non-burnable, like if they're in an urban area, if they're exposed or not, which we're not using inherently in this project, but we could make that. And then the other one, Julie, the other one to bring on here is the risk source to structures. And I guess if we had a risk source to structures, and then do you have structure points to put on top?
You do.
Okay.
Oops.
Oh yeah. What is the answer to that question? How many points is it trying to draw right now?
So it's at 637,000.
Okay, I wasn't too far. Okay, so maybe Julie, zoom in on the northern Bitterroot Valley or Missoula area or something like that. And so I think making a WUI map based on these results is some combination of where structures actually exist and where can fires start on the landscape and impact structures. So that where they start and impact structures is the map, the background map there. That's the risk source to houses. And then we see where the houses are. And so when we've been pioneering making kind of a WUI map idea, it's to generalize the structures. So and then code them whether they're on burnable land cover or non-burnable, and even the non-exposed, like the core of Missoula is not exposed. And then that's the one thing. And then the other one is different zones of landscape based on how fires can impact those housing areas. And that's so some combination of what we're looking at here. We pioneered that in Southern California and showed a quick map, but it was just a pioneering effort. So, but it's like this. Julie, do you have anything to add?
No, I don't.
Okay, thank you. This question, I think, relates to maybe the potential risk to structures versus the actual risk. So why did the Bob Marshall Wilderness show up as a high risk area to structures?
Okay, great. And the answer to that question is really in the question itself, is that it's the risk to potential structures. We map it everywhere as if a structure were there, even if there's not one there. And that's where that potential structure comes in. And in the middle of the Bob Marshall Wilderness has all of the factors needed to present a high threat to structures if one were there, and that there's a very high probability of fire, and the fires that occur there can be with some intensity. Mostly the probability is very high, and the probabilities are high simply because we do a lot less fire suppression in the Bob. We allow fires to get big because there aren't any structures and other resources and assets. So there's not a strong reason to contain fires there. And so the whole reason for doing this, though, right? So we see that if there were a structure there, it would probably be at some risk because the hazard is quite high. But there's no structures there. So, but the whole reason for doing this is largely for not land management planning, but for land use planning. So if a county is going to review a proposed subdivision, if the proposed subdivision is in a place that is bright red here, they might need to look more closely at requirements for mitigating that wildfire risk versus if it's in something else that's already, so there's no houses there yet, but so you look at the RPS to see, well, when you do put houses there, what might it look like and how might that be mitigated? And Julie, scroll just for a second, we're looking at the Sealy Swan there, but we see Rice Ridge, the footprint of Rice Ridge, I should just point out. Yeah, drag that northward. So we're looking at Sealy Lake, and you see that footprint of the Rice Ridge fire in our risk to homes. And so if there were homes in there, if you built one now for a little while, this map would change, right? But there's a relatively low risk now compared to what it was before. But there simply weren't structures in there. So the structures that are still left in the Sealy Lake community, they're still at relatively high risk.
Okay, thanks for that. Now we have a question from Stillwater County. The fire risk modeling data doesn't actually reflect fire occurrence, and how do you account for that? For example, Stillwater County has had significantly more large fire occurrence with structure loss than Carbon County. Carbon has risks, yes, but actual fire occurrence doesn't match the modeling. Can you explain the difference or the rationale there?
Well, not easily, not without being able to look at your data in particular, but everything could be fine in terms of the data might be okay. But so like I mentioned, we did our calibration of by fire occurrence area and not by county. So, but because we're on average right with respect to historical within fire occurrence areas, my guess would be that if we looked at historical fire occurrence within different counties, that it should be pretty good with respect to historical, except that the counties are so small actually. But I guess there is one big reason why some counties could be off, is that we're using a fire occurrence database that is interagency, national in scope and interagency, and it's only about large fires. And there is a chance that fires within counties don't make it into that database, depending on who was responsible for the fire. State and federal fires almost always make it in there just fine, especially if they get above 250 acres. Smaller fires might not have made it into that. So that could be an error that we have that we just have to live with, and because we have to have consistent data across the area. And then I guess, go ahead, sorry.
Signe, this is Mike DeGrosky. Could I chime in real quick?
Yes, please do. Thanks, Mike.
Yeah, I think there's a couple of other things to think about. We know that county reporting in this ties into what Joe just said. County reporting in the state has been problematic over time. And the other thing is some of the historic fires that I think we can remember in those counties fall outside the period that was modeled.
Okay, thanks for that clarification. And I would also like to remind everyone, I'll put my email address in the chat window shortly here, but feel free to follow up with questions via email to me directly, and I'll try to connect you with the right presenter on some of these. So the next question, first a little piece of feedback. This was a wonderful effort to capture the actual values humans are reliant upon. And then a question related to the HVRA. How did you adjust the potential structure modeling for structures that can't be built in places like wilderness?
Well, we didn't have to make any adjustment. So the risk to potential structures map is mapped for every acre of Montana, regardless of whether it can or cannot be built upon. So it's simply because once, I mean, it's actually far easier for us to do the math on every acre, and then it's a separate question about cutting it out to say, well, this isn't buildable, or this is in wilderness, or this is owned by the federal government and it's not going to be built. So we simply didn't do all those cutouts because that can happen after the fact. So I think that's what that question was getting at, is we simply didn't have to, we didn't try to cut it out about where you couldn't build. It's simply the results are everywhere, whether you could build it or not.
Okay, thanks.
I was,
All right.
Signe and Joe, I was trying to display here the analog to risk to potential structures, which is the calculated risk where the structures actually exist. And so the risk to potential structures is everywhere across the landscape, regardless of whether a structure is actually there. Whereas what I just drew here in the pink is where we do know within some radius that the structures are located. But it's the same math.
Oh, okay. So zoom in somewhere. I can't see the pink very well.
Okay.
Or just zoom in and we can see it.
Yeah.
Right. So now, yeah, what Julie's got here, this is the part about risk to structures where they exist, and then risk to potential structures is outside of that.
Okay, thanks a lot for that clarification. All right, we have a couple questions on the urban areas. Can you speak specifically to how the results came out in the burnable urban areas that you talked about?
Sure. And maybe, I guess, Julie, if we put on burn probability and zoom into Missoula. And do you have 0 included?
0 is included.
Yeah, so maybe make that clear, I guess.
Put that base map back on beneath it.
Okay. So, and then I guess to really answer this, we'd have to be able to look at the non-burnable urban, where the actual burnable stops.
So what I just displayed here is in dark gray, the non-burnable. Oops, make it a little darker so it's easier to see. Does that help?
Not really, but zoom into Missoula a little bit, and I think we can actually swipe off. Yeah, this will work when you swipe.
Okay. Burn probability, you want to swipe?
Yeah.
Okay. I'm gonna give it
So
a second to draw here.
the short answer to that question was we found that the results didn't go crazy. We didn't have to do a whole lot to keep it from going crazy. When I say going crazy, I mean doing things a lot different than what we did in the WRC project. For WRC to address this, because we couldn't make burnable urban, we used a post-process. We ended up calling it oozing, right? Where we dragged the probability, let's say for Mount Sentinel, we dragged and oozed it into Missoula, into these urban areas about 1,500 meters, or about 1 mile. And when we did it this way, we didn't put any limits on anything, and we got generally similar results. And so, Julie, if you swipe that right now, we'll be able to see where, okay, there it is, way over there, yeah. So you can kind of see now where, I can't point at it right now, but where Mount Sentinel ends, the grasslands there, and that occasionally a few fires did, yeah, right in there, right? So occasionally a few fires simulated fires did move into the urban area. And then the Rattlesnake Valley, actually, which is in our view here in the upper right, is nicely filled in with burn probabilities. It's lower probability in the Rattlesnake Valley than either side around it, but it's not 0. So if we had not done this, the probability there would be 0. And simply the fires that have occurred in other places in the country have shown us that we don't think that should be 0. It should not be as high as it is around it. And so we do have that decline in probability there. So is this right? We don't know. This is just a first pioneering effort. And the one nice thing too is you can completely remove this effect, because we know where we've added probability onto urban areas, and we could set it back to 0 if we wanted to.
Okay, thanks. I think you may have addressed this, but I don't know if there's anything you wanted to add, whether you considered urban community forest fuels, looking at the urban areas.
It depended on the land fire data. And so the land fire data has a lot of urban fuel, like some parks, some golf courses actually end up showing as burnable. And so anything that was burnable in land fire because of like the veg type that it mapped is still burnable to us.
Okay, thanks. All right, next question. Can you model how possible veg treatments would reduce risk to structures, surface water, or infrastructure? For example, by changing the veg data and rerunning the risk map?
That's a great question, and the answer is yes. And that's exactly what this a framework like this is good for, and why it's nice to do a mechanistic approach like this. And in fact, we haven't done it for this project, but it's possible. What we've done as well is to build like a hypothetical treated fuelscape as if you treated everything, and then what the intensity reduction would be if you treated different places, and then what the risk reduction would be if you treat those places, and use that to prioritize or identify or put together a kind of a fuel treatment project. And then once you get that whole fuel treatment project built that's got spatially allocated where you're going to treat, what it's going to be, how the fuels would change, burn that into the fuelscape, rerun the fire modeling. There's even a feature in FSIM that allows you to rerun it with the same exact simulated fires that it used before, so there's no randomness in it. And then you can see the risk reduction. That is absolutely the right way to go.
Cool, thank you. Just so folks who are still typing questions know, we may, at this point, we've got quite a list of questions to address. So if we do not get to yours, please feel free to email it to me. I put my email up on the chat window, and I can connect you with the right presenter to answer that. So we'll get through as many as we can here, but at some point, for the sanity of our presenters, we'll have to cut it off. So this next question is on evacuation routes. Are there any future plans to tie evacuation constraints or routes to this?
Not from us, but Mike Degrosky or anybody else from DNRC might be able to address that, but not for us.
And
I'll give DNRC a second to chime in here if anyone would like to.
This is Mike. I'll jump in. I'd ask Matt to jump in if he's got a different thought on this than I do. We've not discussed that yet. I think the answer may be that we regard the risk assessment as a decision support tool rather than necessarily a completely comprehensive, all-inclusive suite, or tool. So I don't know. I think that's something we need to talk about, whether folks take this information and use it to help their evacuation planning, or if at some future date we might want to actually include evacuation routes in the risk assessment. My just gut feeling right now is you take this information and you use it locally to plan evacuation routes. I don't know, Matt, do you have something different?
Yeah, Mike, just to add that really those are local CWPP action item related topics that would fit well in those types of plans and efforts at local areas.
Okay, thanks for that. Now we've got a question on smoke. What consideration was given to smoke impacts as an MVC for understanding impacts to communities beyond intensity associated with large fire growth or burn probability?
Yeah, that's a fair question. So smoke impacts to human health is definitely one of the sometimes considered a resource or an asset, which it's neither one of those things, but it's something that fire can affect. And it's been included in a few risk assessments. I generally try to keep it out of the ones that I do because it's incredibly challenging. And it's not just that it's hard, it's not why I want to do it, but you can't get a good answer out of it because we have fires that have risk transmission. A fire starts someplace and that burns fuel someplace else, but then the smoke transmission from where it burns to where the impact occurs is so great that the most that we could really do is say we would have an idea, and somebody could do a separate analysis from these data of the likelihood of fire burning in different places. We know something about the fuel and actually in the vegetation, so somebody could do some smoke modeling about smoke production, the estimated annual smoke production in a given area. But then you also have to be able to do the work about where do we care about the smoke going, and whether you're in the smoke shed or not. And in Missoula, we probably are in about one of the worst places in the country for wildfire smoke because we're sitting just downwind of is one of the most fire-prone areas. There's a ton of fire, and all that smoke comes over the hill and just fills in the valley. And so, that's not even in Montana. And that's the biggest challenge about smoke, which is why we very rarely include them in the risk assessments. But the risk assessment produces information that smoke managers could use in the long run.
Okay, thanks. I'm going to take a stab at combining a couple of questions here, so I'm sorry if I get this wrong, but is it possible to integrate things that might change in lifetime, like structured data or timber harvest, and see how that might affect wildfire risk and values?
Yeah, I mean, so this risk assessment and even the hazard part, it's kind of a snapshot in time, but it can be updated at any interval, and you can also game with it. And you have to do some things like, well, if you added a subdivision and that adds structures to one spot, or maybe that as development occurs, structures are going to go in, and you could include that. But does adding the development and structures, does that also change the fuel? And you could do that. So it's certainly possible. That's what's a real nice advantage of this framework, is that it allows you to do all that kind of sensitivity analysis and what if and do that stuff. The challenge, it can be done. The challenge is that it's really quite effortful to make even small changes. The fire modeling takes long time to run. But there are ways to streamline that, I think.
Okay, thanks. Let's see, I guess we'll move on to a question on the WUI map. How does this WUI map fit with CWPPs and anything else coming out from the federal register?
Well, I'm going to let the DNRC folks answer that, other than to say we haven't really produced a WUI map here. We've produced information that could be used for that in different ways, but Matt or Mike, if you want to address that.
I actually think that's probably a good question for Kristen Sleeper.
Okay.
Hi there, can you hear me? I'm having some internet connectivity trouble over here.
Yeah, you're doing great.
Yep.
Yeah, Sydney, can you just repeat the question for me?
Yeah, the question was on how this data, or how the WUI data in this risk assessment fits in with WUI data from like a CWPP or something from a federal register.
Yeah, so all of the data and the point structure layer that the DNRC has compiled from the Montana State Library is in line with the federal definition of the WUI. And obviously, being a local jurisdiction state, counties can take that information and adapt it to meet their needs, either adhering to the same or a stricter standard of how they define the WUI. And we do plan to make the WUI dataset that the DNRC has compiled available on the open data portal that can be incorporated into these important revisions that counties are doing right now. And so I know I've been working with folks in Lincoln County and in Sanders County and in Ravalli County to really make sure that they have the best map to meet their needs, to ensure that they are prioritizing the right work in the right places to reduce risk to their communities as they sort of use it from their local purview. And so I think that answers the question, but if anybody has specific questions about CWPPs and incorporating the WUI layer, Signe has my email, and my email is online on the DNRC's webpage. We can talk through it and make sure we meet your needs and our local resources sort of have access to this up-to-date and current information.
Thanks, Kristen. We have time for probably just one or two more questions, so I'm sorry we're not going to get to all of them, but we can definitely work on answering some of these via email. This question has to do with any outreach with other states. Did you work with any others that have also developed wildfire risk models, such as Starfire or the IFDIS group? If not, will you be sharing methodology to help achieve these outputs in other states?
Absolutely. And we're actually, this methodology, this is one of the first that we've done at the state level. So we've done lots of forest level and regional level. And but we actually have in the pipeline to do very similar work to this for the state of New Jersey, but also for the state of California. And we did very similar pioneering work in the state of Oregon, well, Oregon and Washington for the Pacific Northwest risk assessment, which is actually where we pioneered the risk to communities stuff. And Alan Ager had done very similar work. And then I think there are definitely other states that are interested. The state of Utah they do really great work too with tying wildfire risk into their budget allocation and some different things. So I think that there are a lot of states moving forward with similar things, and we definitely all share methods. Like some of you might remember the West-wide risk assessment, WWRA. It was 13 Western states, and that had started with a method for the Southern states. And in terms of sharing methods, actually, I had the smallest role possible on the WWRA. I went to their kickoff meeting and brought our concept that we're doing in our framework here of response functions and applied it into their system. And that was many years ago now, right? And so there are a number of different ways of doing these things, and we kind of all share methods, and there are subtle differences, but they're fairly consistent actually.
Okay, thanks. For the last question, I'm going to try to end on some sort of action. So there's two questions. One of them is, how does this fit in with the Montana Forest Action Plan, which should probably be addressed by DNRC. But there's another question on how to best use this resource. Should folks send resources to the locations with the warmest colors, or to the places where they potentially could have a higher impact in prevention, maybe places that wildfire risk is not already off the charts? So I don't know if DNRC might want to address that, and if you can address those two questions in one, that would be great.
Thanks, Signe. Yeah, I'll start off on this one, and we'll let some other folks reply to this as well. I do think we have Wyatt Frampton on, who's the coordinator for the Forest Action Plan, and so I'll let him address the Forest Action Plan question there, Signe. I think as Joe talked earlier, we need to make sure we're looking at the map of average and total and understanding what it is that we're trying to do there, whether that's prioritization of projects or actual allocation of resources. In the future, there will likely be efforts from the fire program and forestry division in those areas, but to this point, they're not lined out or put together at this point. So I'll pass it over to Wyatt to talk Forest Action Plan.
Thanks, Matt. So this risk assessment and the Montana Forest Action Plan's priority area assessment process are two concurrent processes. And given the deliverables of the two products, we haven't had time to fully integrate and overlap these two data sets, but at a future time, we will, as the Forest Action Plan is going to be iterative. We do plan on continuing to do our best to incorporate the most up-to-date and relevant data to deliver an accurate representation of where areas of emphasis in the state should be.
Okay, thanks. Well, with that, I'm going to start wrapping things up here. I want to, before we close, I really want to thank all the participants for taking the time to be here. We realize this is a long webinar, and we're just thrilled to see the diverse range of participants from both Montana and other states and regions. So thank you for your time. And thanks to all the presenters for the great information and really detailed and thoughtful presentations. As you close the webinar, a brief survey will pop up. We would really appreciate your feedback and input. And if you have any more questions regarding this webinar or have requests for future webinars, please feel free to email me or call me at any time. I put my email up in the chat pane, and it should be pretty, oh, Julie's got it on her screen as well. So it should be pretty easy to get a hold of one of us in the future if you need to. Thanks again, everyone, for your participation. Thanks, Matt, Joe, Brian, and Julie, and some of the other panelists that jumped on for questions, for taking the time to share your work with us. I hope you all have a great rest of your day, and please stay healthy. Take care.